Hi everybody, welcome back to my channel on Feynman integration. Today we're going to be doing something a little weird. We're going to be finding the value for -1/2 factorial. Now that doesn't make a whole lot of sense, does it? Because factorial is usually like n times n minus 1 times n minus 2, so on and so on, all the way down to 2 times 1. So how are you going to take that? Well, remember in a previous video, we know that this is true. So, okay, awesome. Now all we have to do is plug in -1/2 and we have the answer, right? Now, yeah, try to figure that out. Try to put in -1/2 for n there and go ahead and try to solve that integral. It'll be tough. But let's do this. Let's use Feynman integration. Of course, it's a channel on Feynman integration. So let's create a function of t that's equal to the integral from 0 to infinity of e to the negative t x squared over x squared plus 1 dx. How's that going to help us? Well, it's tough to see at this point, and I'll admit I did not set out trying to prove that. I was just playing around with Feynman integration, and I got that out of it, so I decided to make a video on how you can use Feynman integration to find the exact value for that. But anyway, this is where we start. Okay, so we know that. Let's see. Well, let's take a derivative, like we always do. We're going to take a derivative with respect to t using the Leibniz rule for differentiation under the integral sign. So 0 to infinity. Okay, what happens if you take the derivative with respect to t of that integrand? You're going to get negative x squared e to the negative tx squared over x squared plus 1 dx. All right. That's not that great yet. So you might notice something that basically this is what we're going to do from here. We already have this x squared. So let's put it inside of parentheses and also put a plus 1 in there. Well, what did that have the effect of doing? Well, it added a factor of e to the negative tx squared, but it actually subtracted it. So we need to add it back in order to have the equations be equal. So we need to add back another integral from 0 to infinity of e to the negative tx squared over x squared plus 1 dx. Right? Yep, we added the plus 1, that really subtracted e to the negative tx squared, so we have to add it back. So that's right. And of course, this and this will cancel. And then this becomes kind of like a Gaussian integral, a little bit. Not quite though, so we're going to have to make a substitution. Let's say u is equal to square root of t times x. That'll give us dx is equal to t to the negative 1/2 du. All right, let's rewrite this. So we have our f of t is equal to, let's see, negative integral. Will this affect our bounds of integration? No, it will not. So we still have 0 to infinity of e to the, let's see, this is just going to be negative u squared. That was the whole point of that substitution. And then dx is simply t to the negative 1/2 du plus, oh, I'm sorry, this was actually our f prime of t. I forgot to write that. And then we have plus this thing, which is exactly our f of t. All right, let me check this to make sure I didn't make any mistakes here. Oh, no, f prime. Yeah, this is f prime of t is equal to negative. See, our dx becomes that. That becomes e to the negative u squared du plus. This is our f of t, so that's all correct. And we know that this whole thing right here will evaluate to negative t to the negative 1/2 times the square root of pi over 2. All right, because now this is the Gaussian integral, and that is the square root of pi over 2. And then we have that minus t to the negative 1/2. All right, so let's call our function of t something else. Let's say y is equal to f of t, just to call it something else, and then we'll rewrite this using I believe this is Newtonian notation. So we're just going to say that the derivative of y with respect to t is equal to negative t to the negative 1/2 times the square root of pi over 2 plus y. Okay. That's nice. Okay, so now what we're going to do is we're going to kind of take a tool from differential equations, and we're going to create an integrating factor. And I'll just show you. Basically, what we're going to do is we're going to multiply both sides of this equation by e to the negative t, and then do some rearranging, and we're going to get this. We're going to get that dy dt times e to the negative t, and then let's see, minus y times e to the negative t is equal to the square root of pi over 2 times, let's see, this is going to be negative t to the negative 1/2 times e to the negative t. All right. Did I make a mistake somewhere? Okay, let's keep going. Let's notice that this is simply the result of a product rule for derivatives on this. If we take y times e to the negative t and just do d dt, that will equal this, because we have the first times the derivative of the second, which is right here, plus the second times the derivative of the first, which is just right there. And actually, I'm going to rewrite that a little bit further over. So we have d dt y e to the negative t is equal to this. Square root of pi over 2 times negative t to the negative 1/2 e to the negative t. All right. So that's true, right? Yeah. Because that's just another way of writing that. All right, so now what we're going to do is we're going to integrate both sides with respect to t from 0 to infinity. Okay. We're going to bring that negative sign out here too. I know it's a little hard to read. Okay, so what's this side going to evaluate to? Well, basically we're taking, let's just take the antiderivative and then evaluate it over the bounds. Well, what's the antiderivative with respect to t of the derivative with respect to t of something? It's just the something. So we're going to basically have y times e to the negative t evaluated from 0 to infinity. And that is going to be equal to negative square root of pi over 2 times, well, what's this? Oh, this is negative 1/2 factorial times negative 1/2 factorial. No. Yeah. Yeah, I really should put an additional bracket around this so we know that we're not actually taking the factorial of this entire product. All right. Okay, so now we just need to find that side. What is this from 0 to infinity? Well, what's our y? Our y is simply f of t. Okay. All right. So what's f of t e to the negative t from 0 to infinity? Well, at infinity, this whole thing is going to go away because we'll have e to the negative infinity, which is 0. And at the point 0, this e to the negative t will just become 1. So we're really just evaluating f at 0. So if we evaluate this function at 0, we'll find what this side is. And if you plug in 0 for here, you get 1 over x squared plus 1, and that's just going to be equal to pi over 2. But don't forget, we're actually subtracting pi over 2. So we get that negative pi over 2 is equal to negative square root of pi over 2 times negative 1/2 factorial. All right, let's multiply both sides of the equation by 2. Get rid of the negative signs. And then divide both sides by the square root of pi. And we simply have that the square root of pi is equal to negative 1/2 factorial. There you go. That's it. Hope you enjoyed that.